Fasteners are critical to proper wind turbine generator operation. Some of these, such as the fasteners used in the tower base, the tower splices, the tower to yaw ring joint, the blade to hub joint, and those used to fasten the hub to the low-speed shaft, are so important that their failure could cause the loss of the entire unit. These fasteners operate under high loads and are subject to extremes of heat, vibration, and load reversals. The technician must be aware of the critical importance of these fasteners when installing, inspecting, or maintaining them in order to avoid a catastrophic loss. This lesson will acquaint you with the terminology used to describe these important components. Bolts are the most common type of fastener used in high-stress applications. The main parts of a bolt are the head, the shank, the grip, and the threads. Bolt heads are typically hex-shaped, but some bolts have an internal socket head. A radius in the area where the shank meets the head protects the bolt from stress cracking. A bolt head is marked to indicate the strength properties of the material that it is made from. Metric strength property markings consist of two numbers separated by a dot. The first number is the minimum tensile strength. The second is the yield strength, expressed as a percentage of the tensile strength. For example, an 8.8 marking indicates tensile strength of 800 MPa. Yield strength is 80% of 800, or 640 MPa. Many U.S. bolts conform to SAE standards, and their strength is shown by radial lines on the head. An unmarked head is grade 2, while 3 lines indicate grade 5. High-strength grade 8 bolts have 6 lines on the head. Manufacturer's marks may also appear on the head. Most head markings are raised rather than stamped. This is because a raised mark must be made during the forming process, but an indented mark could be added later by a counterfeiter. The shank begins under the head and continues to the end of the bolt. The grip is the unthreaded portion of the shank. The threads allow mating with a nut or a threaded hole. When it comes to thread types, technicians are mostly concerned with the thread pitch and class of fit. Thread pitch is the distance from the top of one thread to the next. For metric bolts, this distance is called out directly. A bolt with a pitch designation of 3.0 is designed with 3 mm between the threads. Inch-based bolts use threads per inch, abbreviated TPI, to describe pitch. This bolt has 10 threads per inch. Threads are also defined by the terms coarse or fine. A coarse thread has a larger pitch distance than a fine thread. An M14 by 1.5 is a fine thread. An M14 by 2.0 is a coarse thread. Whether the bolt threads mate loosely or tightly with the threads of the nut is determined by the class of fit. A loose fit fastener has production tolerances that are large, and nuts may be turned on by hand. Tight fit bolts are made with tighter tolerances. Turning a nut on a bolt will require a wrench in most cases. Medium fit falls between these extremes, and many bolts are produced with a medium fit, which provides reduced play, while still allowing most nuts to be turned by hand. In the next lesson, we'll look at the codes used to describe bolts.